Okay, we're moving on to chapter 5. We did 5.3 right before spring break. So we're moving on to 5.4. We'll do part 1 today, part 2 tomorrow. Solving radical equations. So if it's a radical equation, what do you think is going to be in the equation? A radical. Go figure, right? A radical equation is an equation that contains a radical expression with a variable in the radicand. To solve a radical equation involving a square root, first use properties of equality to isolate the radical on one side of the equation. We want to isolate the radical on one side of the equation. So we want to get the radical by itself. Nothing being added to the radical, nothing being subtracted from it, nothing being multiplied by it or divided by it. The radical completely by itself. Then use the following property on the next slide to eliminate the radical and solve for the variable. So first thing we want to do is get the radical completely by itself. There can still be stuff under the radical. There can be an expression under there. But I don't want anything added to the radical, subtracted from the radical, multiplied by it, or divided by it. Does that make sense? And we just use our inverse operations to get the radical by itself. If 3 is being added to the radical, I'd subtract 3 from both sides to get rid of it. 5 is being multiplied by the radical, I'd divide by 5 on both sides. Okay? Still using inverse operations. Am I good to move on? Okay. So, this is the property we can use if we have radicals in our equation. If two expressions are equal, then their squares are also equal. So if I have a number that equals another number, if I square that number, it's also going to equal the square of that other number. Right?
This is like what Carter said about
A equals B, then A squared equals B squared. If 5 equals 5, then 5 squared equals 5 squared. Right? So this is essentially saying that I can square both sides of my equation and it'll still be true. Because one side of an equation equals the other side, right? They're equal, they're the same thing. So if I square one side, I can square the other and it still stays equal. Does that make sense? Yes, no, maybe so. And if I square a radical, that eliminates the radical, and I'd be left with just the expression under the radical. So that's why this is important. This is how I can use this when I have a radical equation. Does everyone understand that? Yeah. Okay. Let's look at some examples. Solve each equation. Letter A, we have the square root of x plus 5 equals 13. Is that plus 5 underneath the radical? No. So, what's the very first thing I need to do?
Isolate it.
Isolate the radical on one side of the equation. So I don't want anything added to it, subtracted from it, multiplied by it, divided by it. Do I have any operations going on with the radical here?
You can minus the 5.
Very good. Yeah, it's square root of x plus 5. So that square root is not by itself on one side of the equation right now, is it? It's got the plus 5 with it. So like we said, we're going to use our inverse operations. We said subtract 5 from both sides. So on the left-hand side of the equation, I'm left with the square root of x equals, and then what's 13 minus 5? 8. Everyone okay with that? Is the square root now isolated by itself on one side of the equation?
Yeah, call from LA. Yes.
Yes, it is. Nothing else is being added to it, subtracted from it, multiplied by it, or divided by it, is it? Now I need to get the x by itself. I need to get rid of that radical. You guys remember how I said we could get rid of the radical? I can square it. If I square a radical, it eliminates the radical. Because this is essentially saying square root of x times the square root of x. Right?
Yeah.
If I multiply by a square root exactly by itself, I just get the thing that's under the radical. So if I do the square root of x times the square root of x, I get x. So if I square a radical, it eliminates it. So I'm just left with x. But based on this property, if I square one side of the equation, what do I have to do to the other?
Square.
I've got to square it as well. So I'm squaring the 8. What's 8 squared? 64. Is x now by itself? Yeah, there's my answer. We okay with that? So x equals 64. If I plug 64 back into my equation to check my solution, what's the square root of 64?
8.
8. What's 8 plus 5?
13.
13. Does 13 equal 13? Yeah, it checks out.
Does that mean the next one's 9?
Questions on A? You okay with A? Can I erase and move to B?
Yep. Wow.
We okay with this so far?
I like these.
Not too bad? Okay, letter B. 3 minus the square root of x equals 0. Trey already kind of figured it out earlier, but let's use our mathematical steps here to get the answer. Is the square root the radical expression completely by itself?
No.
No. What do I need to get rid of? The 3. How would I get rid of that 3 using my inverse operations? Subtract 3 from both sides. It's a positive 3. Yeah.
Could you like rearrange that?
How would I rearrange it?
Maybe do a little square root of x minus 3. Or no?
If you move those around, you would have to keep the signs with them. So that would become negative square root of x plus 3.
Okay.
Yeah. So I do need to subtract 3. I will show you another step here in just a second after we finish this one that you could have done. So like I said, that negative needs to stay with that square root for right now. So 0 minus 3 is negative 3, correct?
Yep.
Is that square root completely by itself now?
No.
No, what's happening to it?
It's negative 1.
Yeah, it's being multiplied by negative 1 essentially, right? This is like negative 1 times the square root of x. So how can I get rid of that negative 1 being multiplied by it? Divide by negative 1, right? Inverse of multiplication is division. If I divide by negative 1, it cancels it out. Whatever I do to one side, I got to do to the other. What's negative 3 divided by negative 1? 3.
There's a tornado.
Okay, is my radical expression now completely by itself?
Yeah.
Yeah, it is. Nothing's being added to it, subtracted from it, multiplied by it, or divided by it, right? Now that the radical expression's by itself, how do I get rid of the radical?
You gotta do the thing.
Got to square it. When I square one side, I got to do what to the other? Square it as well. The square will cancel out the square root. And I'm left with x equals, what's 3 squared? 9. Is x now by itself? Yep, there's my answer.
Awesome.
Questions about that?
No.
Now, there's one step we could have done at the beginning that would have saved us a little bit of time, maybe one more step. I could have added the square root of x to both sides and then squared both sides. Did we get the same answer either way though? Yeah, we did. So it doesn't matter which way you do it. We okay with that? Questions on my example 1, A or B? We okay with this so far? Okay. Okay. Solve 4 times the square root of x plus 2 plus 3 equals 19. Okay. This looks a little more difficult than the ones we just did, but we can still do it. My goal is to still, before I get x by itself, get the radical expression by itself first. Okay? So is the radical expression by itself here? No. What would be my first step to get the radical expression by itself here?
Could you divide by 4?
I would not do that first.
But could
Here's
you should minus.
So here's what I like to do with radical expressions. We could treat the whole radical kind of like its own variable for right now since I'm trying to isolate that by itself. So think of this as like 4y plus 3 equals 19. How would I get y by itself? What would be my first step? Subtract 3, right? So I'd get 4y equals, what's 19 minus 3? 16. And what would be my next step to get y by itself? Divide by 4. So what would y equal? 4. But it's not y, is it? It's my radical expression. So I would get the square root of x plus 2 equals 4 based on what I did down here. Does that make sense? So let's look at it again. Getting the radical by itself, what would we do first? Subtract 3. 4 times the square root of x plus 2 equals, what's 19 minus 3? 16. Do what?
I think I did it.
Okay. And how do I get the radical by itself now? Divide by 4. Square root of x plus 2 equals 16 divided by 4.
4.
Everyone okay with that?
Yeah.
Kind of treating the radical almost like a variable. Now is the radical expression completely by itself? Yeah, it is. There's nothing being added to it, subtracted from it, multiplied by it, or divided by it. I've got operations going on under the radical. That's okay though. The whole radical together is by itself. Right? So, since the radical is by itself, let's go ahead and get rid of the radical. How do we do that?
Square it.
Square it. Got to square both sides. So that'll cancel out the radical. What am I left with on that left-hand side now? X plus 2. Whatever's left under the radical, right? And what's 4 squared? 16. We okay there? Now, I got rid of the radical. Now I can get my variable by itself. How would I get x by itself here? Subtract 2 from both sides. X equals 14.
Easy money.
Easy money. And what's one way I can always check my answer? Plug it back in. What's 14 plus 2? 16. What's the square root of 16? 4. What's 4 times 4? 16. What's 16 plus 3?
9.
Does 19 equal 19?
Yeah.
Yeah, it does. So it would check out. Okay? Questions on example 2?
No.
We feeling okay about this? Everyone not okay? That I need to clarify any questions or anything? Okay, can I move on? We're getting close to being done today. All right, here we go. Now we got a radical on both sides of the equation. Uh-oh.
I don't like it.
So I got the square root of 2x minus 1 equals the square root of x plus 4. Any ideas what I could do here?
What if you just square them both?
There we go. Square both sides, right? What's going to happen when I do that?
You get radicals.
Both radicals go away, right? So what am I left with on the left? 2x minus 1. What am I left with on the right?
X plus 4.
Oh, that wasn't so bad, was it?
Oh,
Now I can just solve for x. If I've got a variable on both sides of the equation, what do I want to do with those variables?
combine.
Get them to one side, right? Combine them to one side of the
this is
equation.
easy.
So how would I bring my 2x over or my x over?
Subtract.
Subtract. Yeah, let's subtract x from both sides. It'll cancel it out over here. Subtract x from over here. What's 2x minus x? 1x or just x. X minus 1 equals 4. How do I get x by itself?
You add 1.
Add 1 to both sides. X equals 5. There's my answer. Plugging 5 back in. What's 2 times 5?
10.
10. 10 minus 1?
9.
9. Square root of 9.
81.
Square root of 9. What number times itself gives you
3.
3? Okay. What's 5 plus 4?
9.
Square root of 9.
3.
Does 3 equal 3?
Yeah.
Yeah, it does. It checks out. Questions on example 3? Still good. Still not too shabby.
Not shabby at all.
Sweet.
The worksheet now.
Here we go.
Boo.
Solve the cube root
Oh!
of 5x minus 2 equals 12.
Cube both ones.
Solve the cube root of 5x minus 2 equals 12. So all our previous examples, we had a square root. So we squared both sides, right? To get rid of that square root. If we have a cube root, Trey, what do you think we're going to do? You said it.
Cube both.
Cube both sides. Very good. If I've got a cube root, I would have to cube it to get rid of it. If I've got a fourth root, I got to raise it to the fourth power to get rid of it. If I've got a fifth root, I got to raise it to the fifth power to get rid of it. And whatever I do to one side, I got to do to the other still. Right? So to get rid of my cube root here, first off is the radical by itself.
Yes.
Yeah, so now I can jump to getting rid of it. I can cube it, and it'll get rid of my cube root. Whatever I do to one side, I got to do to the other. So I'd be left with 5x minus 2 on the left. And then I've got to do 12 cubed. What is 12 to the third power?
1,728.
1,728.
I got the right one down.
It's 12 to the third power. 12 times 12 times 12. And now, I don't have any radicals, do I? This is just an equation that I can solve for my variable. What's my first step to get x by itself? Add 2 to both sides. 5x equals, what's 1728 plus 2?
1,730.
1730. How do I get x by itself? Divide by 5. I've got 1730 divided by 5, which gives me
It's 100. 40 something.
what did it say it was? 346.
No, that was all.
So there's my x value.
No.
So I plug 346 back in. 5 times 346 gives me 1730. 1730 minus 2 gives me 1738 or 1728. Then if I take the cube root of 1728, I get 12. Does 12 equal 12? Yeah, it does. Any questions on example 4? That's all we're doing today. That's my last example for today. Tomorrow, we'll talk about this thing called extraneous solutions, but that's not terribly bad either. But here's what we're going to do for today. Here's our assignment.
Oh my gosh.
Pages 268 through 269, numbers 4 through 44 evens.
8 questions.
You saw how quick they went, especially if you're just sitting there knocking them out. You guys should be good on this. It's probably about like 20-ish problems. Not terrible. Not terrible. I got pencils for you to borrow. Make sure I get it back.
Yeah.
Are there any questions that pertain to my recording before I end the recording?
What's your dog?